we're going to go ahead and take a look at graphing a sine function that has a different amplitude, a different period, has phase shift, and has vertical shift. So it's already in the proper form. Remember, the number in front of your trig function of sine or cosine ends up being your amplitude. So our amplitude's 3. Now, we look at the number that's in front of our angle that's being multiplied by your angle, and that's 4. So we can use our peanut butter. PB is equal to our normal period. You'll notice over in the equation over here that our phase shift is in degrees. So that means we need to have our period also in degrees. So we're going to go our peanut butter period times B is equal to 360. So now we'll go ahead and plug in our B value. So we'll go our period times 4 is equal to 360. Then we'll go ahead and solve it for our period, divide by 4, and we get 90 degrees. Now our vertical shift is the part that's afterwards right here. So that is up 2. Now, we also want to take a look at that phase shift. Once again, the phase shift is that part that's after added or subtracted to the angle. And so we're going to be moving it to the left 90 degrees. By the way, the vertical shift is up 2, which was what we had over here afterwards with the plus 2. That also tells you your equation of your midline. So you go y equals whatever that vertical shift is. So we start out with just our basic sine or cosine graph. But for this particular problem, we're dealing with the sine graph, so we'll start out with that. Remember that sine starts at the origin and then goes up. So I'm going to just draw that without any tick marks. That's, for the most part, my basic sine graph. And then it continues on in each direction past that. So if I wanted, I could extend that. And now I could go ahead and put in my tick marks. So if I put in my tick marks, I know that I go up and down 3. So I know it's going to top out at 3. It's going to bottom out at -3. Now, one full period, it says, is 90 degrees. So I'm going to mark one full period as 90 degrees. So this is 90 degrees. So therefore, halfway in between is 45 degrees. Well, just because I put the tick marks on afterwards, all I have to do now is the phase shift and any vertical shift. As I look at the problem at this point, I realize that my period is 90 degrees and my phase shift is 90 degrees. When your period and phase shift end up being the same, they end up being on top of each other. So if I were to move this whole graph 90 degrees to the left, it would be on top of itself. So the phase shift in this case doesn't really do much. But I still have to do that vertical shift, which means I need to go up 2. So I need to go ahead and move all my key points. My key points are my zeros where I cross the x-axis, and my minimums and my maximums. And I need to move it up 2 points. 2 would be this distance here. That's how far I got to move each one of those key points up. So I'll move each one of those key points up 2 units. Now I just have to draw in my new graph going through those key points. And then it would really continue on past that. And so on. then you should indicate which one is your final graph. So I'm going to put a little arrow and go final. So when you guys are doing these, you should probably use different colored pens or pencils, and or use dotted and dash and then indicate which one is your final one. Now, thinking of this here, I started out at 3, and I moved it up 2, so that means it's going to top out at 5. I was at -3, I went up 2, so it's going to bottom out at -1. Now, if you want a nicer looking graph, that's what we have at the bottom. The scale's a little bit different going horizontal. The one down below is a little bit more compressed, but that's okay. Our tick marks still match. So let's go ahead and try to do the next one. If you can, try to do it on your own without watching the video and then watch it afterwards. So we're going to first of all start out by identifying all the key points. The number in front of your cosine is 4, so that's your amplitude. The number in front of your angle is 1/2, so we're going to use peanut butter. And you might be wondering, why do we have 2 pi here instead of 360? Because when you look at the phase shift, what's being added or subtracted to your angle is in radians, so our period needs to be dealing with radians. So we'll go, our period times our b value of 1/2 equals 2 pi. Divide by negative, or by 1/2, and remember, dividing by 1/2 is the same as multiplying by the reciprocal, so we end up getting a period of pi. Our vertical shift is what's being added or subtracted after the brackets, and that's down 3. So the equation of our midline is y equals -3. Our phase shift is what's being added or subtracted after the angle, and that's that pi over 3. So we'll be going pi over 3 to the right. So now I'm going to start out with my basic trig function. Here we're dealing with sine, or not sine, cosine. Remember, cosine starts at the top and then comes down. And then it would continue on past that. And then if we wanted, we could continue this one on. Now, I did mark over here one complete period. Started at the top, one complete period, ends at the top. So I'm going to mark that as one complete period. In this case, that's 4 pi. So halfway in between would have to be 2 pi. So consequently, this would have to be pi, because that's halfway in between. This would be 3 pi. Then I can come along and I can mark my amplitude. This is 4. Bottom of it, this would then be -4, because it's my amplitude and the opposite of my amplitude. So now that I have my basic graph, I can go ahead and do my phase shift. My phase shift is pi over 3 to the right. Well, first of all, I need to identify those key points. Once again, the key points are the maximums, the minimum, and where I cross. So all these little gold points, I need to move my phase shift, which is pi over 3 to the right. So I need to first of all figure out what pi over 3 is. Well, here's pi. Pi over 3 would be 1/3 of the distance between the 0, 0 and the pi. So I'm going to divide that into about 3 equal parts. So now, this distance right here is how far I need to move all those key points. So I'm going to move all those key points that far to the right. Now I'm going to come back and draw in a smooth curve going between those those points. And so on. Now I still have to go ahead and do my vertical shift. So all those new points, I now need to move 3 units down. So I need to first of all identify what 3 is. Well, halfway in between would be 2, so 3 would really be about this distance here. So all those key points that I drew a little bit ago, I now need to move that far down. So as I look here, I'm going to see if I can get a different color. We'll go with purple. So I need to take this key point and move it 3 units down. Take this key point, move it 3 units down. This key point, move it 3 units down. And continue on. Now I need to go ahead and draw in a smooth curve going between those new key points. But this is my final curve, so I'm going to make this one solid. And then it would continue on in each direction. So then I'm going to indicate this is my final. So once again, start out with your basic sine or cosine graph. Put your tick marks on afterwards. That accomplishes the period and the amplitude. Then do your phase shift on a second graph, and then do your vertical shift on a third graph.